So imagine being a software developer and applying for a new role. And during the application phase, you get promised the stars. We are the best company, we have the best team, we have the best product, we use the best tools, and so on. So the company convinces you, and after signing the contract, it's your first day at work, where it's usually about setting up the machine. And the best case you will encounter on this day is that you will be provided some disk image. Here, everything is set up, just clone this image, and then you're ready to go. The worst case you will encounter is that there's nothing written, so you need to ask your coworkers, sit together with them, and set up your machine, because they got it in their head. The typical case will be, can you please pull the... No. The typical case you will encounter is that you will be referred to the setup script that they have on their Confluence page, on the wiki page, just for you to find out that the setup script is outdated or incomplete. So the first day is over, the first week is over, and during the first month it's usually about getting an overview of the so-called architecture. So slowly you start to realize that of the software they have, that there are no API or source code comments, and the documentation they told you is on the wiki or Confluence is either outdated or completely missing. So you take the courage, you talk to your supervisor about the state of the software documentation, and the probably nicest answer you will get is, well, we don't do that here. And the not so nice answer you will probably get is some kind of. So that was the only time that you mentioned the topic of software documentation. And now you know what you'll have to do at these companies for the following months and years. As long as you will stay there, you will have to do reverse engineering day in and day out. If you ask people why their software documentation is that bad, you usually get one of those three excuses. Excuse number one is, we are agile. Yeah, agile does not mean that you should not do documentation. None of the inventors and none of the authors of agile has ever said or written that you should not do any documentation. If you read the manifesto, there's one sentence that says working software over comprehensive documentation, but it's only a priority. Before you start creating piles of paperwork, first get your software running. This of course makes sense, but it doesn't mean that if you have your software that you should not do any kind of documentation. Excuse number two, we don't have time. Yeah, that's a good one. Or we don't have money, which is usually the same. We could easily do the math. I don't have time for this now, but the math is pretty simple. If you just take into account how much time it saves, especially for new employees, if they had some proper documentation. It saves time for the new employee, it saves time for the old employees, because they don't have to invest so much time to introduce the new employee. And also think about security, because people won't repeat mistakes if at least they got the stuff written down, if they have an understanding of the architecture. I also worked a lot of places where I had no idea of the architecture, and I, as a lot of other people, were just improvising, doing the things. And excuse number three, that's my favorite. The code is the documentation. Yeah. Just dream on. Yeah. Remember, self-explanatory code is only self-explanatory to the person who wrote it. And even if it really was perfectly self-explanatory code, it could only describe a brick, but not the house built of these bricks. In other words, if you got the perfect self-explaining class, method, whatever, it could still not describe software architecture. If you want to learn, or if you want to convince your supervisor, your boss about doing proper software documentation, I wrote some articles during the last years. So this is an article Java doc with style. This is a Python conference, so you don't have to care about the Java doc part, but the introductory sections contain a lot of reasons why you should do software documentation. This was published in a German Java magazine in 2022. Then I translated it into English, and you can find the English blog post here. And then I wrote a more general article about markup languages. You will hear about markup languages in a second, which I also translated into English. And from 2024, there was an interview with me, which you can read here, where I also give a lot of background information about why software documentation is important. And with this shocking introduction, first of all, I want to give you an official welcome. You can find the slides and the examples I'm going to show you at this link, but you do not have to take a picture now, because I will show you the link again at the end of my presentation. So then you can take a picture at the end of the presentation. And 2 words about you. I assume that you are Python developers, professional Python developers, or working on non-small projects. This is where documentation becomes relevant for you, definitely. If you're just a hobby Python developer working on your Raspberry Pi, of course, you're also very welcome. I guess software documentation is not yet very relevant to you, but it's never too early to learn about it. And these are the 3 objectives I have for you. I want to help you clarifying some basics of software documentation. I want that you learn the key aspects of doing Python documentation, and I hope that every one of you has their personal take-home ingredients, their personal take-home messages. And 3 words about me. I've been developing software for a very long time. I have my own company in Switzerland. I'm a certified software developer, so my main language actually is Java. I've done my first certification 20 years ago, and I repeat it from time to time. You can do the same with Python. So just Google Python certifications, which I strongly recommend because it really gives you a push during preparation. I offer a lot of services regarding everything around software documentation. That's why I call myself a technical writer, and I also do software trainings for software developers. This is me. This is my name, how you write it in Switzerland. But since we're here in Lithuania, I saw that you have lots of these accents, these little things at these letters. So I assume that the correct spelling of my name in Lithuania is this one here. So before we dive into Python documentation, I first want to give you 3 basic principles that are very important with respect to software documentation in general. Principle number 1 is audiences and altitudes. Because if someone mentions software documentation, people have different ideas of what software documentation is. He, for example, thinks when he hears the word software, I'm just picking random people, yeah, that is source code comments. We tried that in the past. It's just a waste of time. Nobody reads them. They get outdated. They are wrong, whatever. And another person thinks, like her, yeah, that's software architecture diagrams. They give you overview of the architecture and so on. So who is right? What is software documentation? Is it his version or her version? The answer is there is not one software documentation. There have to be several software documentations at the same time. And usually you have to differentiate these 2 parameters. You have to choose parameter number 1 for a certain piece of documentation. Who do you actually want to address, which is called the audience. Imagine you develop a library at your company, and the documentation you write towards external developers that use the library or end users. This documentation obviously has to look different than the documentation you write for your own internal developers who maintain this library, which again is a different version needed than architects need. And again, product owners speak a different language, managers speak a different language. So all these people need their own version of software documentation. And the other thing you need to think about, which is independent of the first one, is what level of detail do you want to document, which I like to call the altitude. And usually the highest level is some overall software architecture, which you usually do in some external documents. You do some diagrams, and somewhere in the middle where you document classes, interfaces, APIs, etc., you use things like docstrings in Python or Java doc in Java, JS doc in JavaScript. Could also be OpenAI, Swagger, and so on. And only at the lowest level, when it's about function internals, this is where source code comments come into play. They only become relevant once the developer is reading that certain piece of code. In other words, you do not describe software architecture in diagrams. That's just the wrong place. And also you do not describe function internals, function details at global architecture overviews. You need to find the right spot. A good starting point for all this altitude stuff is the C4 model. Don't know if you ever heard about it. C4model.com from Simon Brown. He invented it. It has 4 levels, of course, as the name implies. You don't have to copy everything from it, but it gives you some nice ideas of where you could differentiate those several levels. Principle number 2 is the one of markup languages. I guess you all know what a markup language is. A machine and human readable language for structuring and formatting text and other data. The most common markup language, here it has ML in it, is HTML. So you write pure text and you add some markup elements to it. Anyone knows LaTeX? Usually students learn this at university to write their thesis. This is also a markup language. The problem is, so I've been doing LaTeX for over 15 years, so I guess I know it pretty well, but I still don't like it. These slides are also done in LaTeX. The point is, it contains too much noise. So if you only want to concentrate on text, HTML as well as LaTeX and other real markup languages have too much noise. So they distract you from reading and writing. So in order to not get disturbed by the reading and writing flow, so-called lightweight markup languages were invented. They provide a simpler syntax without disturbing the writing or reading flow. So I give it one try and I put the power on this device here, but that's the only thing I can change. A lightweight markup language is simpler and doesn't introduce or hopes not to disturb your reading and writing flow. So the most prominent lightweight markup language is Markdown. I guess every one of you have heard of Markdown. It's very popular, but restructured text is another one, more extensive one. That's the one you use usually for Python, ASCII doc, or if you ever edited the global Wikipedia, it's the MediaWiki language you used. Let's skip this part here. This is just a diagram where I say that the more you can do with a lightweight markup language, the more complex it is. So on the upper right corner, you see LaTeX. You can do everything with LaTeX, but it's very complicated. And on the lower left, you have Markdown. Markdown is very, very popular, but on the other hand, it's also very, very limited with what you can do. A perfect compromise candidate is ASCII doc or restructured text. That's the red dot over here. And restructured text is the language that's used for Python documentation. Principle number 3 is the concept of docs as code. It simply means documentation is treated like source code. So you do not write your source code in Confluence or any other wiki or SharePoint or Word, whatever. You write it in the same IDE where you do your coding. You check in your documentation using the same version control system that you use for your code. You use the same process integration, technically as well as organizational, which means you also do pull requests, which contain software documentation that should be reviewed, and you can run it through the same pipeline that you already have. And the pipeline, once there is a merge, the pipeline runs through it and also creates the current state of the documentation. This requires the documentation to be in text format, so you cannot create any binary format, which includes Word, LibreOffice, OpenOffice, all that stuff. Theoretically, it's not binary, but it looks like binary, so you should not check in Word files into your repository. You need plain text written in a lightweight markup language so that you can do diff and see what has changed. That's the purpose of it. And you get another big advantage. It's the proximity between source code and documentation. Because one thing I hear a lot from people why they don't do software documentation is something like, yeah, we tried software documentation in the past, but it got outdated. And this is actually correct. Because if you have your source code here, your application here, and you have your software documentation over here, could be Confluence, for example. And if the programmer who is doing something over here is not even aware that something in the documentation is referring to that module where they are working on, then of course they cannot update the documentation. And that's the reason why the things start to drift apart. If you don't even know that there's documentation, of course you cannot update it. Ever used the search function in Confluence? Why are you laughing? Never worked. Yeah, so. Okay, if you move these two closer together, documentation and source code, best thing is write the first thing in the code is the documentation. The first thing of the method is the documentation. Chances are significantly lower that you will miss updating the documentation. So that's the principle. Now that you got the three basic principles, let's specifically do the Python documentation part. Python uses doc strings for documentation. They appear at the beginning of a class or function body. So the first thing, the body, is this doc string. If anyone is familiar with Java, you'd use Java doc for documentation. There's a difference. They appear above a class or method declaration. Python, it's below. Java, it's above. So this is how it looks like. For example, here we have a Python class. This is the body, indented 4 digits to the right. The first thing you here see is the multi-line string. It's just a multi-line string. That's a doc string. We have a function. The first thing in the body is this doc string. You can also read this doc string during runtime with this variable underscore underscore doc underscore underscore. You can also access this doc string, so it has some special meaning in Python. You can try this program and it will work. What is that? Doc strings are data that can be accessed at runtime, and doc strings can and should contain restructured text syntax. First of all, it's just a string. You can do everything you want inside the string, but following convention, it should be restructured text syntax. Now, if you want to learn about restructured text syntax, it's a lightweight markup language, a very extensive one, a very good one. You might start Googling around, but you might probably see 3 different sources. Source number 1 is something from docutils that mentions restructured text. At this link, docutils is the very basic part of the generator. Sphinx, which we will talk about in a second, is built on top of docutils. So this is too fundamental. I don't suggest that you read this one here. Today you use the Sphinx documentation generator. They also got their own primer for restructured text. So this is the source that I can recommend to you if you want to get an overview of restructured text. This is where you should invest your 1 or 2 hours to get an idea of what you can do and how you can do it. If you continue Googling around, you will find something like the Python Developer's Guide, which also has a restructured text markup. This is not relevant for normal programmers. This is only relevant if you're developing the Python core itself. Today we heard a keynote about the Python core, and only if you are actively contributing to the Python core, these are the conventions you need to follow. But if you don't have to care about this convention. So the black one is the important one for usual programmers. When you read literature, Python books about Python books, and of course they have to mention documentation. Usually they don't like to do it, so they have a very thin chapter about documentation so that they at least covered it formally. And then you will usually read things about the help command. The help command can show you the doc strings. Anyone ever use the help command? No? Do you like it? No? Okay. I think this is very outdated, so you don't read documentation on the terminal. This is another thing is PyDoc. This is an HTML generator. The only advantage of PyDoc is that it's included in the Python core. So you don't need to install any third modules. But the HTML documentation it creates out of it look like from 1995. So that's very, very old-fashioned. I also don't suggest that you use PyDoc. The standard today for documentation in Python is the Sphinx documentation generator. By itself, Sphinx only makes HTML out of restructured text. But I guess you want API documentation. So you need this Sphinx API doc program using the AutoDoc extension I will show you in a second, which reads through your Python files, extracts all those doc strings, prepares them, and then another run of the real Sphinx documentation generator then actually creates the real documentation. As I said, you can write everything you want in your doc strings. You should follow some conventions. Officially, it should be PEP 287, but I printed it in gray, which means you shouldn't. Because it's already too cumbersome, so NumPy came up with their own format, and Google even came up with a different format, which is described here, how you should structure your doc strings. And on the next slide, you will see how they should look like, and it's pretty self-explanatory. So the syntax is pretty simple. This is a doc string in Google syntax. Summary, more text, describing the arguments, describing the return values, describing any exceptions or errors that get thrown. Another example, summary, longer information, attributes, etc. So if you follow this convention, you follow the Google style syntax, which is pretty easy and cool. Don't make it more complicated than you need to. You find the description of how to do it at this link here. And you got all the links once you got the slides. And this is something I want to demonstrate to you now. You got everything I will do now written on the slides. I already did this one, and I have it printed out here so I can type it in. And once you got the slides, you can follow exactly those commands. So I promise you I do exactly what was written on the slides. I did the pip install, which is written on the slides. I already installed Sphinx. And now the first thing I need to do is create a directory called docs and go to this directory docs. Now here you see we have a directory docs. Then there's a program called Sphinx Quick Start, which creates your first Sphinx project. I always suggest that you do separate source and build directories. Project name, let's call it PyCon Lithuania. Type in the author. Give it a version number. What about this? Language is fine. Okay. And now you see that inside the stock folder, it created some files for us. Everything you put in source is what the Sphinx generator gets as input, and the output is created in the build folder. And I can now create the first documentation. You do it with make HTML. Then you see that the build folder gets populated, and here you have an index.html file, which I will now copy. Put it in Firefox, and you see, ta-da, this is the first documentation. So this is the first Sphinx project. Now I can show you how you adjust a few things. Everything you need to adjust is done in the conf file For example, I don't like this copyright statement. This looks a little bit weird with the comma and the missing space. So let me adjust in this configuration Python file, put a space here and remove this ugly comma. You can switch the themes. Here it's called Alabaster. Let's choose another theme, so it will look different in a second. Let's choose the classic themes. And also I will add an extension, things contrib.croaky. I will tell you in a second what this is. Now we also included at least one extension. And the index.rst file, this is the restructured text source, which will get into HTML. And let's also put some more stuff in it. So it only says here this, that's the little text that we got. And I prepared something more for you. So I copy all of this and put it in here. And now let's just generate a documentation. Make HTML. So this is fine. Refresh. So you see, different theme. Now it's greenish. You see significantly more text because I added a much longer restructured text file. And you also see that the copyright down here looks nicer. So here you can see how you can write paragraphs, how you can do inline markup, so italic, bold, or code notation. This is easily done like this. So if you put the asterisks around it, you get italic. If you put 2 asterisks around it, you get bold. And if you put these double ticks, you get code notation. You can easily include hyperlinks. You can easily create lists, unordered lists, ordered lists. You can easily include source code snippets. You could also include them from other files. You could easily type mathematic formulas in LaTeX notation. And you can create diagrams. This is what the Croaky is about. Croaky is an API that understands a lot of diagram languages. For example, here we describe a block diagram, A, B, C, D, A, E, F, G. And we describe a UML diagram, animal, dog, cat. So dog inherits from animal, cat inherits from animal, main refers animal, and so on. Now look again. This is the list, ordered, unordered list, ordered list, source code snippet. That's the mathematical formula that you saw. These are the diagrams. Remember where I said A, B, C, D, A, E, F, G? And this is what automatically gets rendered out of it. And this is the UML diagram that I just get from textual description. So this is pretty cool. This is called diagrams as text. So you don't use PowerPoint, you don't use Visio or Draw.io. You don't use your mouse, you just describe the layout using text form. And this is what you get out of it. Anyone heard of Plant UML? Yeah, have a look at Plant UML. This is pretty cool. This is Plant UML. You can do all kinds of UML diagrams just by textual description. So I showed you this, Yeah, I showed you all of this. Now, all you saw is how to render pure restructured text diagrams, but we are here in order to document Python code, so the API. And in order to do so, I prepared a class which is called bank account, and it has a doc string describing an error, another error in that's Google notation, another class, this is the method description, and so on. So you see some sample Python code with some doc strings. Now we want to create the API from it. And in order to do so, let me copy this example to the project, paste, so the directory is bank, and now I need to adjust this config.py, so let's do it like this. So I need to add a a path so that it knows where the Python code is. Remember this bank stuff. And I need to add more extensions. This autodoc, remember from before, and this Napoleon extension. Autodoc means is the extension that can look into other Python files. And this Napoleon is used to understand the Google syntax. So let's add them to our extensions. We don't need those empty lines. And again, let's use another theme just to show you how you can switch the themes. That's the config part I did. We did that one. Okay. And now I run the Sphinx API doc command. This is the one that actually, no, I need more, huh? I need to tell it where to look at. So, got it. Remove the build folder because we want it clean now and make HTML. And now we get a clean documentation, hopefully, and refresh in the web browser. And now you see we got a different theme. It looks different now. And we see the content that you already know. But here we also got this bank API description. And if we now click on bank account, for example, I hope it's large enough that you now see that we got the description from the doc strings. That's the short description, the summary, the parameters, the method descriptions, and so on. So they were all extracted from the doc strings. Yeah, that's it. Demo finished. And everything I did is described here on the slides, including screenshots. If you want to see what kind of themes you can choose from, have a look at this gallery, thingsthemes.org, and try to pronounce thingsthemes.org. That's funny. Thingsthemes.org. If you want to convince yourself, or if you want to convince your supervisors that you should now start using Sphinx and do more documentation instead of Confluence, have a look at those projects. There are hundreds of open source projects documented using Sphinx. So go through this list, choose some nice ones, and just get an impression of how professional documentation can look like if you use the right tools. In this case, Sphinx and restructured text. It looks significantly more professional than all the stuff you could ever do with Confluence or Word or whatever. Especially, I picked some examples. Python itself is documented using Sphinx. You know this yellow Python page. Here the CSV page, for example. NumPy, you know, NumPy is also documented using Sphinx. Pandas is documented using Sphinx. I picked some nice examples here. You can click on them once you are at home and see the slides. Matplotlib and so on. So all these major projects are documented using Sphinx. The nice thing is they are all open source. So if you want to see, well, I like the page, how did they do it? Watch out for a GitHub button. Often you can jump directly to the GitHub repository. And in this case, in the case of ND array of NumPy, here you can find the restructured text source code of how they wrote the documentation, which is pretty cool. So you can also learn. If you see something nice in documentation, you want to know, well, how did they do this? You can have a look at the source code and find out how they did. Good, that's the Python part. But remember, this title also said, well, couldn't we also use AI for this? Now we got 2026. Why should we do this by hand? Today, everyone talking about AI. So I'm also talking about AI. Otherwise, this talk wouldn't have gotten accepted for this conference. Can't we use AI? And in order to answer the question, first, one fundamental thing. I strongly believe that software documentation is something that should be provided to the reader and not something that should be searched for. When you look at the picture done by AI, on the left, you see software documentation is provided. Here, read this, new employee. If you read this, invest 1, 2, 3 hours, whatever, you get an overview of the things you need to know. I made sure that the information I gave to you is enough that you can go on your own, that you're safe continuing on your own. On the right, you see many places I've encountered by my own. Perhaps you need to hunt for information. You need to read through the source code. You need to look at Jira tickets. You need to look at the test cases. You need to talk to your coworkers. You need to read through Slack archives, perhaps some old emails, some Confluence, graveyards, whatever. You need to mentally compose your puzzle, which is very, very time-consuming and very, very hard work. So if you now think, okay, let's just upload all the source code of the company's product to ChatGPT, which, by the way, is a very bad idea, just telling you. But let's just imagine you do so. And then I could ask my chatbot everything I want to know. Hey, can you please explain this class to me? But why is it like this and that? Might work, but this is again hunting for information. You are searching. You are asking somebody, doesn't matter if it's a human being or a robot. But again, you are asking. You are trying to gain an understanding. And also think, this chatbot can also tell you what's written in the source code. But I think the documentation should be about the things that are not written in the source code. Especially, I call it invisibles, the whys. Why have we done the things as they are? Give you some warnings. Hey, don't use this method in a multi-threaded context because of race conditions. You don't have multi-threading in Python, but you know what I mean. Some emphasis. It is very important that in order to use, before you use this method, you do this and that. Some decisions. We decided to use Django instead of Fast API because of. If it's written down somewhere, other people will not start questioning this again. We used Angular instead of React. We discussed it 2 years ago. These were the pros, these were the cons. We decided, let's go with Angular. We don't need to discuss it again. Background and context. We tried different, it didn't work, so don't try it again. New employee, we tried it again. So these are the invisibles, and they are cannot be seen from the source code. So don't use AI? Well, I did not say that. Today we got some nice things. They are called RAGs, Retrieval Augmented Generations, which means, and all chatbots do this today, AI looks up the relevant information before answering. You see that when you type something in ChatGPT, that it looks up web pages and so on. You could now tell the RAG to use all the resources in your company, which of course include the source code, but it could also have a look at the architecture, the diagrams you did, decisions. There are also ADRs, architecture decision records. There's some format for it. All the discussions you had, the trade-offs, the history, perhaps the Jira tickets, and so on. And then you could ask your chatbot. But wait, isn't all of this documentation that you had to do before? So, in order for RAG models to perform well, they need documentation. Because, as you now know, source code alone cannot provide this. Now, very important, good documentation is more important than ever because of AI. Because in the future, you wanna, or even today, you wanna use the AI tools. It's even more important that you provide them good information. You came here hoping for the opposite, right? I'm sorry. So, very important, remember this. That's what the Dalai Lama said. If we document well today, AI can support us tomorrow. Or was it Jesus? I don't remember. Another thing you need to think about is what should be the single source of truth. I now differentiate between specification, that's stuff you write before you do the coding. Source code, this is what you do during coding, obviously, and documentation, I just differentiate it now to be more clear, is the stuff you write after you do decoding. Now, which of those three should be the single source of truth? I've worked at companies and they said that's absolutely clear, the source code is the truth. Ever said this or hear it say? The source code is the ultimate truth. Not the documentation, whatever, the source code is the truth. Sounds cool, but isn't, if you think about it. If the source code really is the truth, it also means that you don't have any context. And it also means that all the bugs the application has, and by the way, every application has bugs, are also regarded as the truth. I don't think this is a good idea. Okay. Then the documentation we write after is the truth. This is better, but only if you provide it with context, what we discussed before. But have you ever thought about this? The paperwork that you create before you start coding, defining this as being the single source of truth. So everyone in the company needs to agree, the specification we did before, this has to be the single source of truth. If the source code does something different, then it's wrong. And this is perfect because it gives you perfect food for the developers, and it gives you perfect food for the agents, because today now everyone does agentic coding and so on. But again, they need very specific and correct information in order to perform well. So I'm not a friend of agentic coding, but that's a different topic. But if people want to use it, you need to concentrate on the first one. This needs to be regarded as the single source of truth. What else could you use AI for? AIs today, they are based on these large language models. They are trained on vast amount of text to understand and produce language, so they do a perfect job in it. We all know ChatGPT and get perfect answers, at least in German and English. I also assume in Lithuanian language. So why don't you use LLMs for what they can do best? They are perfect at doing language, so use it for accurate spelling, use it for correct grammar, use it for clear writing. And you have no idea how many documentations I've seen that start with spelling mistakes after 3 words, sentences that do not finish, sentences that do not make sense, grammar that doesn't make sense, no matter if it's English or German. It's just horrible. What do you think is my expectation, or what's the expectation of a reader? That much text and it starts with bad grammar, spelling mistakes, and it looks like, okay, they didn't even invest 30 seconds in it. What's my expectation of the rest of the document? So, proper language and spelling matter. I've seen this in German and in English. The German in Switzerland, where I live, is significantly worse than the German that you have in Germany. Unfortunately, I don't know how it is in Lithuanian, but doesn't matter which language. Correct language and spelling matter. So let's summarize. In order to do good documentation, you need a lightweight markup language. If you are in the Python world, no discussion, it's restructured text. There's no reason to choose a different standard. You would be non-Pythonic. It would be very weird if you chose some other language. And follow a docs as code approach. So write the documentation the same way as you write source code. Think about organizational issues. I could do some more slides, but I don't have time. I haven't prepared them here. If everyone is responsible for documentation, then no one is. You know that? Yeah, we can all do documentation. Everyone can update whatever. Who does it? No one. Because he can. Why should I do it? He can also do it. And he thinks the same. No, why should I do it? He can do it. I guess you know what I mean. It's called diffusion of responsibility. So I'm strongly convinced that documentation should be isolated, or should be the responsibility of very few people. Those who are good at it and those who want to do it. 1, 2, 3 people, not more. You could call those people technical writers. You could call them doctators. You could call them documentation managers, whatever. That's their role. but I'm strongly convinced, because I've never seen the opposite work, that few people should be responsible doing the documentation, setup, responsibility, organization, and so on. Think about getting documentation guidelines. For example, the GitLab documentation style guide. You should not copy it, but just get an idea of all the things that should be that could be regulated over time, because companies regulate everything: code formatting, variable names, parking rules for employees, whatever. But if you ask them, can you tell me what's your regulations regarding software documentation, you usually get something like, well, we have Confluence and everyone can write their stuff in there. No, it's not. There need to be rules in order to do nice documentation. And AI provide human documentation as context for other humans and AI today or later. Use AI for language, but definitely don't use it for reverse engineering. Any questions? We got 2 minutes, I think. Now you can take a picture. The link at the bottom is where you can find the slides and the examples. Thank you so much for listening. And if you got a question, we got a microphone here. You please use the microphone. And I personally am open to 1 or 2 questions. Thank you so much.